Dear learners, let's look at another example. A flywheel of moment of inertia 80 kilogram meter squared, rotating with an angular velocity of 6,000 radians per second, was braked uniformly and it comes to a stop in 30 seconds. So what was its angular acceleration as at the time the brake was applied? How many evolutions did it make during this time? And three, the torque that the brake supply to the rotating flywheel. Okay, so we are given I. Here is I, moment of inertia, and here is our omega. But because it was braked and it comes to a stop in 30 seconds, it stopped means that we have another omega, angular velocity. So here we call it the initial angular velocity. And here we call this one the final angular velocity, which will be 0. And the time for it to reach 0 meter per second is 30 seconds. Okay? So what's the angular acceleration? You can know that straightforward from all the equations of motion. The evolution is theta and torque is straightforward. Torque, we know, when we obtain alpha here, from 1 here, we can obtain torque because torque is a product of torque, tau, is a product of moment of inertia and half. Evolution is the theta. Okay, so very straightforward. Let's see. Solution. I is 80 kg meter squared. Omega subject I is 6,000 radians per second. Omega subject F is 0 and T is 30 seconds. So angular acceleration, why the brake was applied? B, that formula, rate of change of the angular velocity. Okay, and substitute the values. 0 minus 6,000 radians per second over 30 seconds. And the answer is minus 200 radians per second squared. At least it is coming to a stop. That means negative sign shows that it is decelerating. The angular velocity is reducing. And that's why it came to a stop. It reached 0. Okay? So we know our alpha. Then revolution made within that 30 seconds. Revolution made. You can get that from the formula here. Number of resolution. Theta is omega of I t plus half alpha t squared. Okay, so just put your values there. Omega of I is 6,000 radians per second, your t is 30 seconds, your alpha is minus 200 radians per second squared, and your t again is 30 seconds, then squared. So everything 6,000 times 30, that's 180,000, then 200 times 30 divided by 2. Okay, 30 seconds means 900 seconds squared. That's 200 divided by 2. So you have 90,000 radians. And if you subtract that, you have 90,000 radians. And in revolution, remember that 2 pi radians, one revolution is 2 pi radians. So to get the more revolution, you divide your 90,000 radians by 2 pi. Okay? Remember that you took that one revolution is equal to 2 pi radians. So if you have 90,000 radians, revolution divided by 2 pi. So you have 14,320 revolutions. So in 30 seconds, the flywheel makes 14,324, approximately 14,324 revolutions. Okay? Then the last part is the torque applied to it. okay, which is the product of the moment of inertia and the angular acceleration. Okay, that's 800 kilogram meter squared multiplied by minus 200 liters per second squared. So the value is negative. That is, that torque causes is a frictional torque. It brings the flywheel to a stop. So that's why we have our answer as a negative value. God bless you. I hope you understand this too.